Tornado shapes. Tornadoes are one of nature's most mesmerizing and terrifying displays. To the untrained eye, they might all look like simple funnels reaching from storm to ground. But in reality, tornadoes come in a wide variety of shapes and sizes. Some are skinny rope-like tendrils. Others are wide, wedge-shaped monsters that seem to swallow the horizon. Some even appear as multiple funnels dancing around each other. These shapes are not just random. They are the visible results of storm dynamics, atmospheric conditions, and the environment around the tornado. Understanding why tornadoes take different forms helps meteorologists, storm spotters, and the public better interpret what they're seeing and how dangerous it might be. The rope tornado. The most iconic and perhaps least threatening-looking tornado is the rope tornado. As its name suggests, this tornado appears long, narrow, and twisting like a rope hanging from the sky. Rope tornadoes usually occur in two scenarios. Sometimes they are small, weaker tornadoes from the start, often short-lived and less destructive. Other times, they represent the final stage of a stronger tornado's life cycle. As the tornado dissipates, the funnel stretches, narrows, and becomes distorted by winds, giving it that rope-like appearance. Although rope tornadoes often look delicate compared to massive wedges, they can still produce damaging winds. In fact, some rope tornadoes retain significant strength during their final moments, which makes them deceptively dangerous. The cone tornado. The classic tornado most people imagine is the cone tornado. This shape features a wide base near the cloud and a narrower funnel touching the ground, resembling an upside-down cone. Cone tornadoes form when the storm's rotation is strong and stable, but not yet maximized in width. They are often larger and more powerful than ropes, capable of producing EF2 or EF3 damage on the enhanced Fujita scale. These tornadoes are relatively easier to recognize from a distance and often photographed due to their striking textbook appearance. They represent a middle stage in tornado development and can either intensify into wedges or weaken into ropes, depending on storm conditions. The wedge tornado. Perhaps the most feared and dangerous shape is the wedge tornado. Unlike ropes or cones, wedge tornadoes are wider than they are tall, with a massive footprint on the ground. They can span over a mile in diameter, giving the impression that the entire horizon is rotating. Wedge tornadoes are often associated with the most violent storms. Many EF4 and EF5 tornadoes in history have been wedges, including the 2011 Joplin, Missouri tornado and the 2013 Moore, Oklahoma tornado. Their wide bases often make them appear slow-moving, but in reality they can travel quickly and devastate everything in their path. Because of their sheer size, wedges are extremely dangerous. They are harder to visually distinguish from the surrounding rain and clouds, and spotting their edges can be nearly impossible. For meteorologists, radar and debris detection become crucial tools when dealing with wedge tornadoes. The stovepipe tornado. Some tornadoes take the form of a stovepipe, a thick, cylindrical funnel that maintains roughly the same width from cloud to ground. These tornadoes often appear as vertical columns, almost like giant smokestacks. Stovepipe tornadoes are usually well-organized in tent systems. They may be a stage in the growth of a cone or wedge tornado, or they may maintain their stovepipe shape for their entire lifespan. While visually distinct, stovepipes can be deceptive. Their clean, simple outline often masks extremely violent winds within. The multi-vortex tornado. One of the most complex tornado forms is the multi-vortex tornado. Instead of a single funnel, the tornado contains several smaller subvortices rotating around a central circulation. These subvortices may appear and disappear rapidly, whipping around the main funnel like dancers in a storm. Multi-vortex tornadoes can be extremely destructive. The smaller vortices often produce localized streaks of severe damage, ripping apart one house while sparing another just a few yards away. This explains why tornado damage paths can look erratic, with complete destruction in some spots and minor damage nearby. The most powerful tornadoes in history, including many EF5s, have displayed multi-vortex behavior. For storm chasers and scientists, spotting multiple vortices within a storm is a sign of immense rotational energy. The rain-wrapped tornado. Not all tornadoes are easy to see. Some form within heavy rain and are rain-wrapped. Instead of a clear funnel, all that is visible is a swirling mass of precipitation or sometimes nothing at all. Rain-wrapped tornadoes are particularly dangerous because they are effectively invisible. Residents may hear the roar of the storm or see walls of rain approaching, but the actual tornado inside cannot be distinguished. These tornadoes are common in the southeastern United States, where high humidity and heavy rainfall often obscure funnel structures. For safety, meteorologists warn that when storms are rain-wrapped, people should never wait to see a tornado before seeking shelter. Radar signatures, not visual cues, become the most reliable indicator. The satellite tornado, sometimes smaller tornadoes, form around a larger dominant tornado. These are called satellite tornadoes. They orbit the main tornado like moons around a planet, spinning independently but influenced by the same storm system. Satellite tornadoes can occur in powerful supercells, and while often weaker than the main funnel, they still pose serious threats. Their unpredictability and proximity to the primary tornado make them difficult to track and extremely dangerous for storm chasers or anyone caught nearby. Land spouts and gustnadoes. Not all tornado-like structures form the same way as classic supercell tornadoes. Landspouts are narrow, rope-like funnels that form without a rotating mesocyclone. Instead, they occur when surface winds converge and stretch upward into a growing thunderstorm. Landspouts are typically weaker but can still cause damage similar to EF0 or EF1 tornadoes. Gustnadoes, on the other hand, are short-lived vortices that develop along gust fronts, the leading edges of thunderstorm outflows. They can look like small tornadoes but are usually weak and shallow, lacking the connection to a storm's mesocyclone. These structures highlight the diversity of vortex phenomena that can resemble tornadoes, though their formation mechanisms differ significantly. Why do tornadoes change shape? The shape of a tornado depends on several factors. Stage of life. Tornadoes evolve through different shapes as they form, mature, and dissipate. They may start as thin ropes, grow into cones or wedges, and end again as ropes. Storm environment. The strength of rotation, moisture levels, and wind shear determine how wide or narrow the tornado becomes. Stronger storms often produce larger funnels. Visibility. Rain, dust, and debris can obscure or distort how a tornado looks from the outside. A rain-wrapped wedge might look like a dark wall of cloud rather than a distinct funnel. In short, tornado shapes are fluid expressions of storm dynamics. They shift based on atmospheric energy, storm structure, and even human perception. The misleading nature of appearance. A critical point for public safety is that a tornado's shape does not always indicate its strength. Rope tornadoes can still produce deadly winds. Wedges are often violent, but not every wide tornado is catastrophic. Stovepipes may look clean and organized, but that can signify extreme power. This is why meteorologists rely on radar data, damage surveys, and storm reports rather than visual shape alone. For the public, the best practice is to treat any tornado warning as serious, regardless of how the tornado looks. Scientific value of tornado shapes. For scientists, tornado shapes are more than aesthetic differences. They provide clues about storm organization, rotational intensity, and potential risks. Studying why tornadoes appear as wedges, ropes, or multi-vortex systems helps researchers refine forecasting models. Advanced radar and drones are now being used to map tornado shapes in real time, linking appearance with wind speed, debris fields, and pressure drops. The ultimate goal is to better understand tornado dynamics, improve warning systems, and reduce fatalities.